Hello everyone and welcome to Intellipaat. There are currently two versions of the Internet Protocol, IPv4 and IPv6. The IPv4 was created during the 1980s for the US defense networking purposes. They did not think about the boom of the Internet as we know today. Later, foreseeing the need for more addresses in the future due to the increasing IoT devices, IPv6 was introduced. In this video, let us deep dive into the concepts of IPv4 and IPv6. But before we go any further, make sure that you subscribe to our YouTube channel and hit the bell icon for regular updates. Alright guys, now let us take a look at the agenda for today's video. So the first topic in our agenda is what is the Internet Protocol, followed by the need for IPv6, and finally we'll be talking about the key differences between IPv4 and IPv6. Let us move on with the first topic of this video, which is what is the Internet Protocol. The Internet Protocol is a set of rules that govern how data should be delivered over the internet from one node to the other node, that is from the source node to the destination node. The Internet Protocol often works in parallel with the Transmission Control Protocol, that is nothing but the TCP, which is again another protocol or a set of rules, and this TCP essentially separates the data to be transmitted into smaller versions which are called as packets, and this is done because for the need of efficient transmission. And since they both are codependent on each other, they are generally referred to as the TCP/IP protocol. Now let us take an example of how the Internet Protocol is used in real life. So when an email is sent from an email server using the simple mail transfer protocol, also called as the SMTP, the TCP layer of that particular server divides the message into numerous packets, numbers them, and then sends them to the IP layer for the transmission. Each packet will be transmitted to the destination email server at the IP layer. And if you look at the diagram, while each packet is bound for the same destination, the path that they travel there may differ. That is, the data will get broken down into numerous smaller versions called as packets, and all these packets may choose different routes, but in the end they will arrive at the same destination. And when it finally arrives at the destination server, which is on the right side, that is another computer, the IP layer passes it on to the TCP layer, which reassembles the packets into the message before passing it on to the email application layer. Application layer is the final layer and where it appears in the inbox. So this is the graphical representation of the data, and it will be represented in the inbox of that computer. Now IP defines the format of all the data sent over the internet. Now if you look at the diagram below, it basically means that the Internet Protocol is of 32 bits and there are several pieces to this address. So if you can take the example of the messages, that is mail in real life, telegram. So in order for a telegram to go from source to destination, you need to put in the address. So the address will contain your name, full name, followed by your street address, followed by the city that you live in, and followed by the state and your pin code. So this is the rule that we follow while sending a telegram in real life. So the same thing can be paralleled to the IP here. So this is basically the address and all of the small bits that are included in the address. So we have the version, the IP version first, and we have IHL, type of service, and total length, and all these other different versions that you should be putting in before sending it off to the hardware layer for transmission over the internet. IP provides the interface to the network interface level protocols. The physical connections of a network transfer information in a frame with a header and data. The header contains the source address and the destination address. Now IP uses an internet datagram that contains information similar to a physical frame. The datagram also has a header containing the Internet Protocol addresses of both the source and the destination of the data. Alright, now let us move on to the next topic, that is why there was a need for IPv6 when we already had IPv4 in use. So there are currently two versions of the Internet Protocol, that is the IPv4 and IPv6. The IPv4 was created during the 1970s for the US defense networking process, and they did not think about the boom of the internet as we know today. Later, foreseeing the need for more addresses in the future due to the increase in IoT devices, IPv6 IPv6 was introduced. The IPv6 adoption rate globally is around 34%, but in the United States it's about 46%. All the carrier networks and the internet service providers have been the first group to start deploying IPv6 on their networks, with mobile networks leading the charge. So there are more mobile networks with IPv6 addresses than the regular traditional computers out there. The IPv4 is the fourth version of the IP, which establishes the rules for computer networks functioning on the principle of packet exchange. It can uniquely identify devices connected to the network through an addressing system. Whenever a device gets access to the internet, whether it is a switch, PC, or other devices, it assigns a unique numerical IP address as shown below, which is 192.149.252.76. So the IPv4 uses a 32-bit address scheme, allowing to store 2 to the power of 32 addresses, which will be approximately equal to 4.19 billion addresses. The increasing end users connected to the internet leads to the exhaustion of IPv4 addresses. That's also why the new internet addressing system, that is the IPv6, is being deployed to fulfill the need for more internet addresses. So as you can see in the diagram below, the IPv4 address consists of 4 bytes and each byte consists of 8 bits. And the IPv4 address format is also called as the dotted decimal notation because you have dots separating each of the bytes. Alright, moving on to IPv6. The IPv6 was deployed in 1999, concerning that the demand for IP addresses would exceed the available supply. It allows communication and data transfer to take place over a network. IPv6 is a 128-bit IP address which supports 2 to the power of 128 internet addresses in total. The use of IPv6 not only solves the problem of limited network addresses, but also resolves the barriers for multiple access devices to connect to the internet. So IPv4 has this problem of connecting multiple access devices. So IPv6 also solves this issue. An IPv6 address could be written something like this as shown in the image below. So this basically consists of 1 2 3 4 5 6 7 8 bits, and it is separated by a colon, and each byte is represented by a hexadecimal number, and that is why the IPv6 address format is also called as the colon hexadecimal notation. And if there are zeros in any bytes, that is complete zeros in any of the byte, you can omit the address and append a colon next to it. So this will mean after this there are zeros. So this basically saves memory storing the address. Alright, now that we have a clear idea of what IPv4 and IPv6 is, let us know the key differences between them. Okay, so I'll be listing out a few differences here. First is the compatibility with mobile devices. Coming to IPv4, the addresses use dotted decimal notations, which makes it less suitable for mobile networks. Coming to IPv6, the addresses use hexadecimal or colon separated notations, which makes it better suited to handle mobile networks. And coming to the mapping metric, address resolution protocol in IPv4 is used to map to the MAC address of the devices. And when it comes to IPv6, neighbor discovery protocol is used to map to MAC addresses. So basically IPv6 is faster in mapping the MAC addresses of the devices. So the next metric or a factor is a dynamic host configuration server. So when connecting to a network, clients are required to approach dynamic host configuration servers, and when it comes to IPv6, clients are given permanent addresses and they are not required to contact any particular server. So this particular factor makes IPv6 a little bit faster than IPv4. And coming to the next factor, which is internet protocol security, it is optional in IPv4 and in IPv6 it is mandatory. So you have higher security in IPv6. So this is not necessarily desired by companies which has already adapted IPv4. So adapting IPv6 addresses throughout their enterprise and putting it up on all their devices takes a lot of time and effort. So companies right now are sticking to IPv4 as of now. And coming to the next factor, which is optional fields. Optional fields are present in IPv4 and it is absent in IPv6. So it saves data while you give an header to a packet and send it off for transmission. Coming to the next factor, which is local subnet group management. The IPv4 uses Internet Group Management Protocol, or also known as GMP for short, and IPv6 uses Multicast Listener Discovery, or MLD. IPLD for short. And when it comes to IP to MAC resolution, IPv4 is used for broadcasting ARP, and when it comes to IPv6, it is used for multicasting the neighboring solicitation. And coming to address configuration, it is done manually or via DHCP. And coming to IPv6, it uses stateless address configuration using the Internet Control Message Protocol or DHCP6. So these are all protocols, and DHCP6 is the most recent version of the protocol, and it is faster as well. So IPv6 clearly wins in this factor. Coming to DNS records, that is domain name service records. Records are in address, which is a single A, and records coming to IPv6, it is 4 A's. Coming to packet header, packet flow or QoS handling is not identified in IPv4, and this also includes checksum options. Coming to IPv6, flow label fields specify packet flow for QoS handling. Alright, moving on to the next factor, we have packet fragmentation. So it basically structures how a packet is fragmented. In IPv4, the packet fragmentation is allowed from routers when sending to hosts, and for coming to IPv6, it is only used for sending to hosts. Alright, moving on to the next factor, packet size. The minimum size is 576 bytes, and when it comes to IPv6, minimum size is 1208 bytes. So packet size is bigger in IPv6 so that you can send more data. Coming to the security, it depends mostly on the applications. So the security options are included in the applications, that is the end user or end nodes. They can adopt whatever security measures that they want. But coming to IPv6, it implements its own security protocol called the Internet Protocol Security, or IPsec for short. Alright, moving on to the next factor, which is mobility and interoperability. Network topologies are relatively constrained, which restricts mobility and interoperability. So it is restricted in IPv4, and when it comes to IPv6, it is embedded in the network devices. So the IPv6 is very mobile and interoperable, and that is why they use it on the mobile networks in the present day. When coming to SNMP, it is not supported in IPv4, and it is supported in IPv6. Alright, going on to the next factor, which is address mask. So the mask is used in IPv4 in the host portion, and it is not used in IPv6. This extra step is eliminated in the IPv6, and hence IPv6 is a little bit faster when compared to IPv4. When it comes to address features, in IPv4 we have network address translation, which is used, and that in turn allows a single NAT address to mask thousands of non-routable addresses. And coming to IPv6, direct addressing is not possible because of the vast address space. So you can share IP addresses in IPv4, but it is not possible in IPv6 because there are already a lot of address spaces available, so sharing here doesn't make sense. And coming to the next factor, configuring the network. Networks are configured either manually or with DHCP, and coming to IPv6, it has auto configuration capabilities. Coming to routing information protocol, IPv4 supports RIP routing protocol, and IPv6 does not support RIP routing protocol, which is anyway outdated protocol. So IPv6 has its own protocol which it follows. Coming to fragmentation, it is done by forwarding and sending routes, and coming to IPv6, it is done only by the sender. The next factor is virtual length subnet mask support. So the supports are added in case of IPv4, but it is not supported in the IPv6 version of the IP. Coming to configuration, to communicate with other systems, a newly installed system must be configured first. Coming to the IPv6, the configuration is optional. Going on to the next factor, which is the number of classes that are present. 5 different classes are present in IPv4, that is from A to E, A, B, C, D, E. Coming to IPv6, it allows for unlimited number of IP addresses to be stored. So it is virtually unlimited number of addresses, and many classes are also present. Coming to type of addresses, in IPv4, it can be multicast, it can be broadcast, it can also be unicast. And coming to IPv6, it can be anycast, unicast, and multicast only. Alright, the next factor is checksum fields. So IPv4 has checksum fields. For example, this is the format of the checksum. So it is another security measure adopted by IPv4, and it is not present in IPv6. So in IPv6, it is this process, the checksum process is skipped because it already has the security layer underneath it. Alright, moving on to the last key differences. The first one we have is length of the header filed. It is 20 in IPv4. When it comes to IPv6, it is 40 bits and 20 bits respectively. And coming to the number
number of header fields, it is 12 in IPv4 and 8 in IPv6. And coming to the address method, it has a numerical address and it is an alphanumerical address. As we already saw in the previous slides, IPv6 address has hexadecimal. Each byte is represented by a hexadecimal number. That's why it has alphanumeric characters inside it. Coming to the size of the address, it has a 32-bit IP address, and coming to IPv6, the address space is 128 bits. Alright, thank you for watching till the end, guys. Have a nice day.
Just a quick info, guys. If you want to make a career in cybersecurity, then Intellipaat has a post-graduation certification in cybersecurity and ethical hacking by ENICT Academy, MNIT Jaipur. This course is of very high quality and cost-effective, as it is taught by MNIT professors and industry experts.